Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is set 3 of 5 good problems on the topic of comparing exponents. If you have not watched the previous set 1 and set 2 of 5 good problems based on comparing exponents, then I strongly suggest and request that you please watch those videos as well to have a good practice of this kind of problems. This video is part of the playlist Maths 8 Hot. HOT Hot stands for High Order Thinking, where I come up with relatively harder problems on the topics and chapters as and when they are completed in the other playlist, that is CBSE Maths 8 RS Agarwal. If you are new to my channel or not yet subscribed, and if my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 5 good problems of set 3 on the topic of comparing exponents. Okay, so I have the set of 5 good problems on the left hand side. The link of the PDF of these 5 good problems will be there in the description below. As always, please try to solve these problems in 30 minutes, taking approximately 6 minutes per question. Only when if you are stuck in solving any problem, or if you want to see my method of solving it, then please watch this video. And please note that there is no single method of solving a problem. Any mathematical problem can be solved in various ways. I will be solving it in my way based on my understanding and knowledge. You might be you might be solving it in a different way, which might be a better solution. In any case, please stick to the method which is more understandable and comfortable to you. Okay, so let's start solving the problems. Question 1 says that for what value of x is the statement 3x square less than square of 3x false. So if it is given that 3x square is less than square of 3x, then for what value of x this will be false. Now the choices are -3, 0, half and 1. Now let's see if we can, if irrespective of the choices, if we can find the value of all the possible values of x for which we will have 3x square less than square of 3x. Okay. So if this is so, we will slightly rewrite the right hand expression, the RHS. This is known as the RHS. You can consider this as the RHS and the LHS of this inequality. This whole expression is an inequality where the inequality sign is less than. So we have, it is given that 3x square is less than square of 3x is 3 square x square. So we are given that 3x square is less than 9x square. Now in any in any inequality relation, in any inequation, this is an inequality. If you have any inequality of the form, let's say kx is less than ky, not let's say k, let's say we have k1, let's say k1x is less than k2y, where x and y are some variables and k1 and k2 are constant. Then I can then I can divide both the LHS and RHS by the same non-zero constant. So I can divide both sides by k1 and k2, where of course in this case k1 and k2 are non-zero constants. So this will imply that k1x divided by k1 will also be less than k2y divided by k1. So this implies that x1 will be less than k2 by k1, x not x1 but x will be less than k2 by k1 y. This we can do. Now this I just explained using less than inequality. It could be greater than or even less than equal to or even greater than equal to. So we can divide any inequality by the same non-zero constant, constant. But remember, by the same non-zero positive constant, k1 has to be non-zero positive constant. So in this inequality, if I divide the both sides by 3, I get 3x square by 3 is less than 9 by 3 x square, and this implies x square is less than 3 x square. Now you might be thinking that of course x square will always be less than 3x square, but remember one choice is 0. If you consider x as 0, we will have, so you can see that this implies that 0 square is less than 3 multiplied by 0 square. You can say for x is equal to 0. Now this implies that 0 is less than 0. This is a false statement. 0 is never less than 0, and 0 is also not greater than 0. 0 can be equal to 0, but 0 is never less than 0, or 0 is never greater than 0. So if I put x equals to 0, then we can clearly see that for x equals to 0, this inequality is false. So definitely the answer will be the choice B. And also notice that as a side note, apart from 0, if you consider any value of x which is not 0, this equation will always be true. That x square will always be less than 3x square. X square is a positive number. X square, whether x is positive or negative, x square is a positive number, and so definitely if you multiply that positive number by 3, it will be a greater number. So x square will always be less than 3x square, only except if x is 0, then this statement is false. So the correct choice is B. The correct choice is B. Okay, let's do question number 2. Which one of the following is the greatest? Which one of the following is the greatest? So as you can see, all the numbers choices are in the form 1 by something, 1 by some exponential term, 1 by some exponential term. Now please note one thing, that if x and y are some positive integers, x and y are positive integers, let's say greater than 1, then x greater than y, if x is greater than y, this will imply their reciprocal of x, that is 1 by x, will be less than reciprocal of y, that is 1 by y. Also, if x is less than y, this will mean that 1 by x will be greater than 1 by y. This thing you must understand. So now, so you can now clearly understand that it is asking the greatest of all the choices, and as you can see, all the choices are, so the numbers are 1 by 3 to the power 198, 1 by 27 to the power 64, 1 by 9 to the power 100, and 1 by 81 to the power 49. Now among all these numbers, as they are in the form 1 by, the greatest will be the one whose reciprocal will be the smallest. So if I just try to understand that, if I have to decide whether 1 by x is greater than 1 by y or not, if I have to decide whether, or check whether 1 by x is greater than 1 by y or not, I will check whether the reciprocal of 1 by x, that is x, is less than y or not. So the greatest of all these numbers which are in the form 1 by some positive numbers greater than 1 will be the one whose denominator is the smallest. So I will now, so the task remains that I have to find the smallest among all the denominators. That is, smallest, I have to now find the smallest denominator. So now the problem we have to solve is we have to find the smallest among the numbers 3 to the power 198, 27 to the power 64, 9 to the power 100 and 81 to the power 49. Whichever is the smallest, whichever is the smallest, then definitely the answer will be the reciprocal of that smallest number will be the greatest. Okay. Now how do we now solve whether, how do we know which one of these numbers, exponential terms, will be the smallest? So as you can see, the first thing we need to check is that whether all the bases, in this case the bases are 3, 27, 9 and 81, whether all the bases can be expressed as a power of same number, as a power of common number, which we can. If I can express all the base as a power of 3. So 3 remains 3. So we have 3 to the power 198. 27 can be expressed as 3 cube. So the number becomes 3 cube whole to the power 64. 9 can be expressed as 3 square. So this is 3 square whole to the power 100. And 81 can be expressed as 3 to the power 4. And we have whole to the power 49. I will further simplify the exponential terms or the numbers applying the laws of components, laws of exponents, that is power of a power, and it so it becomes 3 to the power 198. This becomes 3 to the power 64 multiplied by 3, which is 12 192, and this becomes 3 to the power 200. And this becomes 3 to the power 49 into 4, which is 36 and 196. So now we have to, we are finding the smallest number of these numbers, and we can see all these numbers are having the common base 3. So we can now clearly compare the powers. The smallest power, the number having the smallest power will be the smallest number. So definitely the smallest power is this. So this implies that 3 to the power 192, which was originally 27, which was the original the denominator, which was originally 27 to the power 64, which was the denominator of the second choice. So this implies that this is the smallest denominator. The idea is that if you are given some numbers in the form 1 by m, where m is some numbers, it could be integer, it could be exponential term, whatever, then if you are asked to find the greatest, then you have to find the smallest denominator, the number having the smallest denominator. So in this case, 27 to the power 64 is the smallest denominator, and this will imply that 1 by 27 to the power 64 is the greatest. Hence the correct choice is B. B is the correct choice. Okay, let's do question number 3. Which one of the following is the least? Which one of the following is the least? We have to find the smallest number. So the numbers given are 2 to the power minus 1 whole to the power 156. 4 to the power minus 1 to the power 79, 128 to the power minus 1 raised to the power 23 and 8 to the power minus 1 raised to the power 54. Now small observations you have to make. All the bases you can see are, these are all exponential numbers, and all the bases are also exponential term having the same power minus 1. Now power of minus 1 means reciprocal. So this is actually half to the power 156, 1 by 4 to the power 79, 1 by 28 to the power 23, and 1 by 8 to the power 54, which again can be this is an exponential form. So this is an exponential, all the numbers are in the exponential form, and if I convert them to rational forms, it will be 1 by 2 to the power 156, 1 by 4 to the power 79, and 1 by 128 to the power 23, and 1 by 8 to the power 54. The problem is asking which one of the following is the least. Now to find the least number among these numbers, definitely I will find the greatest of all the denominators. I will find whichever the number among these numbers whose denominator is the greatest will be the least number. So I need to find, now check which number has the greatest denominator. So now let's concentrate the denominators. 2 to the power 156, 4 to the power 79, 128 to the power 23, and 8 to the power 54. My task now is to see which of these is the which of these numbers is the greatest. Okay, now as you can see that all the bases can be expressed as a power of 2. So let's express all these numbers as a power of 2. So we have 2 to the power 156, 4 will be 2 square, so this will be 2 to the power 79 multiplied by 2, that will be 158. 128 is 2 to the power 64 into 2, 64 is 4 cube, which is 2 to the power 6. So 2 to the power 8 I guess is 128. No. 128 is 64 into 2, and 64 is definitely 4 cube, and we have 2. So this is 2 to the power 6 multiplied by 2, so this is 2 to the power 7. 2 to the power 7, so we have 128 to the power 23 is will be 128 is 2 to the power 7. So this whole will be 2 to the power 23 multiplied by 7, that is 21, 161, and 8 to the power 54, 8 is 2 to the power 3, so it will be 2 to the power 54 into 3, 162. Okay, so we have this. So now we can see all these numbers are having the same base 2. So now we can compare them by the powers. We are finding which of these is the greatest. So definitely the greatest will be 2 to the power 162. So this implies that 2 to the power 162 is the greatest. So this implies that definitely 8 to the power 54 is the greatest denominator, So this will imply that 1 by 8 to the power 54 is the least number among the given choices. So the correct choice is D. D is the correct choice. Okay, let's see question number 4. Question number 4 says that it is given that p to the power q, and q is also raised to the power r, is equal to 512. Then find the minimum possible value of p into q into r, where p, q, r are positive integers. So p, q, r are positive integers, and definitely positive integers. Okay, so that now what is this? Now if you are confused by the left hand side exponential term, it is actually p is raised to the power, and that power is q raised to the power r. We have this. And as a side note, never do this mistake that p to the, if you see any kind of exponential term like this is never equal to p to the power q and this whole raised to the power r. No, this is wrong. The actual interpretation is p is raised to the power, and that power is q raised to the power r. Okay. Now it is asking, so we can, so you will see that we can assign various integer values to p, q, and r, so that p raised to the power q to the power r will be 512. Among all those values, we have to consider those values of p, q, and r, so that the value p multiplied by q multiplied by r will be minimum. This is the problem. Okay. Now let's quickly see what are all the possible values of p, q, r, so that p raised to the power q raised to the power r will be 512. Okay. Now let's try to express 512 as p to the power q to the power r. Now the simplest way is that the p can be 512. If p is 512, then definitely q to the power r has to be 1, because over here we have to be 1. If I consider p as 512, then definitely its power has to be 1. Now what is the power? The power is q to the power r. Now if q to the power r is equal to 1, then obviously if q to the power, okay, if q to the power r is 1, then there are some possible values. Okay, I think we have to do it systematically. Let's say okay, let's say if p is equal to p 100 and if 512, if p is 512, then q to the power r has to be equal to 1. Q to the power r has to be equal to 1. Now what can the possible values of q and r be, so that q and r be, so that q to the power r is equal to 1? We can have 1 to the power 1 or 1 to the power 0, but 1 to the power 0 will not be an option, because it is given p, q, and r are all positive integers. 0 is not a positive integer. 0 is not a positive integer. 0 is also not a negative integer. The positive integers are basically the natural numbers, that is 1, 2, 3, 4, 5, 6. So this option will not be considered. So if p is 512, the only option is q raised to the power r has to be 1 to the power 1. So in this case we will have, this implies q is equal to r is equal to 1. So this implies that p multiplied by q multiplied by r will be 512 multiplied by 1, which is 512. So this is a possible value of p q r, that is p multiplied by q multiplied by r. This is a possible value. Now at this stage only I can clearly say that the answer will be 512. The answer will be choice D, because all other choices are less than 512. In the given choices, Oh, sorry, it is asking then find the minimum possible values of P, Q and R. So we have to find the minimum value. We have to find the minimum value. So definitely, now we have to check. We have to check whether P, Q and R can be 18, 12 or 12, 18, 12 or 24 or not. Okay. So if P was P is 512, then definitely Q and R has to be equal to 1. So what can P be? Can P be okay? So some power. So what can P be so that we can raise it to the some power which will be equal to 512. P can be now at this stage it is P, Q and R. It is very essential that we should solve it in a way that will take less time. Now, instead of actually finding all the possible values of P, Q and R, so that P raised to the power Q raised to the power R will be 512, that might take some time. I mean, you could be very fast in doing that, but I think it will take time for me. I'm just wondering if there is any other better way. So how about see the individual choices? Since the question is asking to find the minimum possible value of P, Q and R, let's try the minimum choice, that is 12. Let's try the choice 12, that is if there can be some value of P, Q and R, so that P multiplied by Q multiplied by R is equal to 12, and also P raised to the power Q raised to the power R will be 512. So P P multiplied by Q multiplied by R is equal to 12. So what can the possible values of P, Q and R be? That is, we have to we have to factorize 12 into 3 factors. Now 12 can be factorized as remember that P, Q and R, none of them will be 1 because they are all positive integers. So we have to start from 2. Okay. And there are 3 numbers. How can we factorize 12 into 3 factors where each factor is greater than 1? Okay, so definitely it can be 2 multiplied by 2 multiplied by 3, 2 multiplied by 2 multiplied by 3, 3, 4, no, it cannot be 6, 2, 1. I think this is the only combination of P, Q and R, so that the P, Q and R are all positive numbers, that is they can be 1. Oh, they can be 1 because P, Q and R are positive numbers, so they can be 1. That is, they are all starting from 1, greater than equals to 1. Okay, so this can also be 4 multiplied by 3 multiplied by 1. This can be 2 multiplied by 6 multiplied by 2 multiplied by 1. What else can it be? I think these are the possibilities. Now the factors can be either 2 to 3 or 4, 3, 1 or 2, 6, 1, irrespective of the fact that whether P is which factor is P or which factor is Q or which factor is R, that is whether P is 2, Q is 2 or R is 3, we can change that. Okay. Now the thing to note is that can we select a value, can we select P, Q and R, so that from these possibilities so that P raised to the power Q raised to the power R is 512. So if P, Q and R is if p, q and r are the factors 2 and 2 and 3, can uh, can we use the numbers 2 and 3 in the form p raised to the power q raised to the power r, so that its value will be 512. By that I mean, can so if we consider PQR as the factors 2 and 2 and 3. Now which one is P, whether P is 2 or whether P is 3, whether Q is 2 or Q is 3, that is a different issue. But can we arrange P, Q and R? Can we arrange P, Q and R so that can we assign values to P, Q and R from the numbers 2 and 3, so that P raised to the power Q, this raised to the power R will be equal to 512 or not? This we have to check. So what can the greatest number be using 2, 2 and 3? It can be, will it be now since 512 is a power of 2, so it has to be 2 raised to the power 3. So so this means basically I am trying whether it can be 2 to the power, and the power is 2 to the power 3, that is 2 to the power 8. What is 2 to the power 8? What is 2 to the power 8? 2 to the power 8 is, I think, 512. 2 to the power 8 is 512, because what is 512? 64 multiplied by 2 is 128. Again multiplied by 2 is 256, and again multiplied by 2 is 512. This is 64 is 4 square, which means 2 to the power 4. So this is 2 to the power 4, and again we have 2 to the power 3. So 2 to the power 7. 512 is 2 to the power 7. 512 is 2 to the power 7. 128, 256, okay, 3, 464 is 4 cube, which is 2 to the power 6. Sorry, this is 2 to the power 6. This is 2 to the power 6, and we have 512 is 2 to the power 9. 2 to the power 9. So definitely 2 to the power 9. Okay. So definitely we can create this 2 to the power 9 in the form of P to the power Q to the power R as 2, and then this whole raised to the power 3 square. 3 square. So where P is equal to 2, Q is equal to 3, and R is equal to 2. So definitely we can see among all the given choices the minimum is 12, and indeed we can find the values of P, Q and R, so that P raised to the power Q raised to the power is 512, where P is equal to 2, Q is equal to 3, and Q is equal to R. So definitely the correct choice is B. B is the correct choice, and P into Q into R is the minimum possible value of P into Q into R is 12. I don't know whether my logic or explanation was clear enough, or whether this is the best way of solving this problem, but this is the only way I could possibly think of. If you have a better way of solving this problem, then you can please let me know in the comment section. Just by giving some hint or suggestion, I will appreciate that. Okay, let's do the problem number 5. Okay, so it is given x to the power 400 is less than 4 to the power 600, then find the greatest possible integral value of x. Integral value of x means x is an integer. Now, that integer could be positive integer or negative integer. X cannot be x. Okay, so let's see. So this is given. If this is so, then what will be the greatest possible integer value of x? Okay, so whenever I said that whenever we have to compare this kind of exponential terms, first we will check whether the basis of the numbers can be expressed as a power of some common base. Now we have x and we have 4. We cannot we don't know what is x, so we cannot express both x and 4 as a power of some common base. So that choice is not possible. That way of solving it is not possible. The next way is I will try to see whether whether the powers is having a HCF, that is if HCF not equal to 1. In that case, I will try to express both the numbers with a common power, and that common power will be the HCF of the powers of the given numbers. So I know that HCF of 400 and 600 is possibly 200. Okay, so I will try to express both x to the power 400 and y to the power 600 in an exponential form where both will have the power of 200. So I know that x to the power 400 can easily be converted in the exponential form with a power of 200 as x square this whole raised to the power 200. And so we have this less than inequality, and 4 to the power 600, if I want to express this number as a power of 200, I know it will be 4 cube and this whole raised to the power 200. So now I have both the numbers having a common power 200. I now just need to compare the base. I mean, it is already given that this is less than this. I mean, whenever you have x to the power m less than y to the power m, where x and y are some integers, positive integers, and also m is also positive integers, then you can always say that x is less than y. So applying this concept, I can say this will imply that x square is less than 4 cube. So this implies x square is less than 4 cube means 64. Now you have to apply basic arithmetic basic logic or basic results or common sense of arithmetic and see what can the greatest integral value of x be, so that x square is less than 64. We know that 8 square is equal to 64. So 8 cannot be the value of x, because if x is 8, then 8 square will be 64, and 64 is not less than 64. 64 is not less than 64. So we have to now we have to check the next smaller integer value, that is 7. Now what is 7 square? 7 square is 49, and definitely 49 is less than 64. So the greatest possible value of x is definitely 7. The greatest possible value of x is 7, and hence the correct choice is C. Okay, so this was another set of 5 good problems based on comparing exponents. I hope this set of problems will give you a good understanding of how to apply the laws of exponents and the fundamental logic to compare two exponential terms, and so there is not much variety of problems based on comparing exponential terms. The basic pattern is that you will be given some numbers. The numbers will be in exponential terms, exponential form, that is some base raised to the power something. You have to tell which one of them is greatest or least. But remember that if all the exponential terms are in the form of 1 by m, then, and if you are asked to find the least among them, then the least one will be the one where the denominator is the greatest. And if you are asked to find the greatest one will be the one having the least denominator. This thing you have to keep in mind. So I think this video will be beneficial to you in understanding the concepts so that you can apply them in problems based on comparison of exponents. If this video was beneficial, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. If you have any kind of questions related to any specific problem or any specific concept that I have discussed or applied, please feel free to let me know in the comment section. I will definitely answer your queries. So thanks for watching. I will end the video here. Until the next video, take care and bye.